In Python, asking if two things are the same is actually not as simple as it sounds. It turns out Python has a few different tools for the job, and you can think of them like detectives, each with a very specific way of looking at the evidence. So let's dive in and figure out what in, is, and equals are really asking.
Okay, let's start things off with a central mystery. We've got two lists here, A and B. They look completely identical, right? But are they truly the same in Python's eyes? The answer might just surprise you, and I promise by the end of this, you'll know exactly why. First up on the case is our membership detective. This investigator has one mission and one mission only, to find out if a particular suspect is part of a larger group. It is all about confirming presence. The tool for this job? The in operator. Think of it like this. You're showing the detective a photo and asking, hey, is this person in the lineup? It simply checks if a value exists somewhere inside a sequence and gives you a straight-up true or false. Nice and simple.
So let's look at some evidence. Here, we're basically asking three questions. Is the number 2 in our list? Is the capital letter O in our string? And is the number 3 in our dictionary? Let's see what the detective found out.
And the results are in. The first one is true, just like you'd expect. But check out the second one, it's false. That's because Python is case-sensitive, so a lowercase o is a totally different suspect from an uppercase O. Now the third one is true, and this is a really crucial point. When you use in on a dictionary, it only checks the keys, not the values. That's a classic trip-up.
And of course, every good detective has a partner. The not in operator does the exact opposite. It's how you confirm that something is definitely not there. Super simple, but also super useful.
All right, let's bring in our next investigator, the identity detective. Now, this one is way more strict. It doesn't care if two things look alike, it wants to know if they are the exact same thing, right down to their very core.
This detective's special tool is the is operator. It checks if two variables are pointing to the exact same object in your computer's memory. You could have two identical twins standing side by side, but the is operator is basically checking their DNA to see if they are literally the same person. It's all about that memory address.
Let's look at a clear-cut case. First, we make a list and call it A. Then we say C equals A. Now listen closely. We are not making a copy here. We are just giving that exact same list a second name, C. So when we ask Python, hey, is A the same thing as C? What do you think it's going to say?
Of course, it returns true, because A and C aren't just similar. They are literally two names for the very same object, pointing to that one single spot in memory.
All right, it is time for the showdown. Let's go back to our original mystery, the case of the identical twin lists. And let's bring in our detectives to crack this thing once and for all.
And here we are again. We have created two separate lists, A and B, that just happen to have the same values inside. Now, based on what we just learned about our super strict identity detective, what's your prediction for A is B?
And the result is false. Whoa. Even though they look identical, A and B are two completely separate list objects, each living at a different address in your computer's memory. They are identical twins, but they are not the same person. So what gives? If is doesn't work here, how do we check if they have the same stuff inside? Well, for that, we need a different tool entirely, the double equals operator. This is our equality checker. Let's see what happens now.
And there we go. True. See, the equals operator couldn't care less about memory locations. It just looks inside the boxes, compares the contents one by one, and since they match, it says, yep, these are equal in value. Okay, so here's the absolute core of it all. Is checks for identity. It's asking, are you the exact same object? But equals checks for equality. It's asking, do you have the same content? This is precisely why A is B was false, but A equals B was true. They're two different objects that happen to hold the same stuff.
But just when you think you've got it all figured out, Python throws us a massive curveball. There's a secret little optimization happening behind the scenes that can lead to some very surprising results. So to save memory and speed things up, Python actually pre-creates and caches a bunch of common unchangeable objects. This includes small integers, usually from -5 all the way up to 256, and a lot of simple strings. This whole process is called interning. And check out the result of this. When you create two variables and set them both to the number 5, Python doesn't actually create two new number 5 objects. No way. To save space, it just points both variables to the single pre-existing number 5 object it already has in its cache. And that is why num1 is num2 suddenly returns true. The same thing often happens with simple strings. This is a classic gotcha that can trip up anyone if you're not expecting it.
Okay, we've investigated the evidence, we've uncovered the secrets. Now it is time for the final debrief, a clear, simple guide on which tool to use for which job so you can write cleaner, more correct code every time. Think of this slide as your go-to cheat sheet. Use in when you need to check for presence, is something inside a container. Use equals when you need to compare the values of two things. And you should really only use is when you specifically need to check for identity, to see if two variables are pointing to the exact same object. That's actually less common, but it's crucial when you're checking for things like none.
And that brings us to our final question. And this one is for you. Now that you know the difference between identity and equality, I want you to think about your own projects. Where might a hidden is versus equals bug be hiding in your code right now? Finding and fixing that one little bug is what makes understanding these details so incredibly powerful. Thanks for watching.